Good morning, everyone. I hope you're having a wonderful day. I just woke up, so I'm kind of tired, to be really honest, but it's a beautiful day outside, so that's always a win. Today, I'm going to be showing you how you can use Swift and a microcontroller and communicate serially using the ORSSerialPort Library on GitHub. I've been using it a little bit. I don't use it. Well, I had a lot of time. I spent a lot of time trying to figure out a really good method, and this was probably the best one I found. And there's just hardly anything documented online, so I thought I'm gonna adapt the documentation into a video form and just sort of explain what I'm doing. So the library I'm using is called ORSSerialPort. I'll link it below because it's really good and very well documented. And to include this package in my project, I'm going to hit code, I'm going to click copy URL to clipboard, come back into my fresh project, Swift UI project in Xcode, and I'm going to right click and select add package dependencies. I've already used the library before, so it's already there, but you can just paste the URL into the search bar and then hit add package. Once you've done that, you're ready to start programming. So first thing we want to do is we want to import our library. Import ORSSerial is the name of it, and we can go ahead and create a class that we're going to be using to interface with our Swift UI view. So we're going to just get rid of that pretty view as well. We're going to call this class Swift Serial, although that looks like that might be, I know if you Google Swift serial libraries, it comes up, so we're going to call that something else. We'll call that ORSSerial. I really can't think of anything else. And it's going to be a subclass of the NS object class as well as the ORSSerialPort delegate class, which is a protocol or a delegate or whatever Swift terminology is. It doesn't matter, but you want these two as subclasses. Straight away, our new class ORSSerial doesn't conform to the protocol because we haven't included the required methods that we must have, which we'll get to a bit later on. Cool, so the first variable we're going to create is our serial port variable, and that has optional type ORSSerialPort. This is just all things I found in the documentation. So we're going to call it serial port, and its type is ORSSerialPort. Secondly, we're going to start creating some functions for opening, closing, and sending data through that serial port. So we're going to go and create a function called open serial port. It doesn't need any sort of parameters. It doesn't need to return anything, which is great. I just need serialport.open, and we can just come and, what am I doing? We can just come and copy that and replace the open method to close for the serial port library. They're really simple, really good. I'm going to make another copy of that, and we're just going to call this send data on serial port. This time we want to be able to pass in a string to this method or function or whatever you want to call it. So we're going to pass in string of type string. Still doesn't need to return anything, which is pretty good. And we're going to send through that string. But we're going to get an error from the compiler because the required type that send needs is a UTF encoded data. So what we're going to do is we're going to create a variable here. We'll just call it x because it really doesn't matter. And we're going to, what does this say? Returns a data containing a representation of a string encoded. So we're encoding the string with our UTF representation of the string. I don't know, that's probably didn't really make much sense, but it's alright. And instead of passing string into our send function, we're going to pass an X, and we have to force unwrap it as well, which isn't great, but whenever we call this function, we're required to have a parameter, I think. I'm pretty sure. I've only been doing Swift for about 2 months now, I think, but my background is in C++, C, embedded C, so it's a bit of a change for me, but I'm liking it. It's good to have that balance. Right, what we're going to do is we're going to initialize this class also. So we're going to call our initializer. Oh yeah. So what is this? I don't know. I'll be honest, I don't really care. We don't need it. We have our initializer. We need to specify a path of type string and also a baud rate of type integer. What we're going to do is we're going to now assign our serial port variable that we created above on ORSSerialPort objects. This is like the base class or whatever, the what we're trying to implement with our serial communication. So we're going to pass in our path variable there, which is pretty cool, and we might as well also set up our baud rate while we're at it, so we can pass in baud as an NS number. We have to specify all these as optionals, otherwise the compiler gets really upset. But because this is when we instantiate our class, we're going to be passing in these values and just hoping our path is correct, which yeah, it will be. If it's not, then there might be problems, but this is just intended for a really basic setup. Cool, so we're going to specify also our number of stop bits, and we're going to initialize the parent classes, because SSS serial, not ORSSerial, if you will, is a subclass of our ORSSerialPort delegate class. I think it's a class. I'm pretty sure it's a class. Let's see. No, it's a protocol. But that's alright. It's just, it is what it is. Before we can assign our class and our delegate functions that we implement, we have to call super.init. The compiler wants us to, right? It's a really bad explanation. Anytime the compiler wants us to, it's just not great. What we're doing in this line here is we're just saying, hey, ORSSerialPort delegate, we're going to be using you. We've got our own delegate functions with some just some basic print statements that we're going to be using to provide some general feedback, and then ORS, the protocol handles all the stuff behind the scenes. It's great. Alright, I've got my notes next to me, so the next function we're going to create is one of the ones required, well, one of the optional ones from the port delegate protocol, and it's called SerialPort. And this is all just on the repository, on the GitHub repository, the repo. Oh man, I'm so tired. So the first one we're going to do is called SerialPort, and this is for if data has been received, if we can detect data received on the serial line, which is pretty cool. So we're going to just copy the parameter interface, you know, what it says in the documentation. We create our object SerialPort. It's of type ORSSerialPort we create our object. We have that as our name for our object that we pass into the parameters or whatever. We don't have to handle any of that. Some of these explanations are not there today. Once we've done that, we can call if let string ns string, and the data we want to pass in is, whoops, this data here. So what exactly this did receive is, I'm not entirely sure, but we have, it is, I wonder if we can jump to the definition of that as well. It's defined here. It's all right. We're going to be decoding, encoding, one of the two. Our data back from UTF-8. Our format that we specified beforehand. And we're just going to print out on a new line our string, which we've created a variable for here. Alright, this is meant to be ORSSerialPort, and that function should be happy. Type string has no member encoding. That's because it has a capital E. Alright, the next thing we're going to create is our delegate function for if the serial port was removed. It's going to autofill it for us, which is pretty nice, and then we can just, if the serial port has been removed, we want to set our object to nil. We don't have an object anymore, right? The path we specify and our initializer is no longer valid, so we just set our variable here back to nil. Okay. I don't know why that, maybe I had a typo or something. I did, yeah. Oh dear. And now if we jump to that definition, okay, it doesn't work still. That's alright, if anyone knows why, please let me know, that'd be pretty cool. Next function we're going to create is our serial port for if we encountered an error. So this is just another one of the delegates defined. I'll show you whereabouts. It was defined. Here, if you click getting started, it's all in Objective-C, but that's alright. Oh, where was it? Here. These are all the methods that you can implement, which is pretty cool. With one required, which I don't think we've got to yet, because maybe we have. So we're going to fill out the arguments that are required to pass in, just based on what was defined in that documentation I showed before. Pass in your serial port. Did it encounter an error of type error? And if it did, we're just gonna say error. Just really simple. You can have more, because you've got the error variable here. You can like figure out what that error was, but this is just quick and cheap. We're going to copy that and paste that, and just serial port was closed and serial port was opened are the other two we're going to do. print out serial port closed and serial port opened. Cool. Once we've got that, our class that we've created, ORSSerial, is ready to go. We can come down to our view container, our view structure here, and we can create a new object. We'll just call this connection line. And we're going to create our new serial object from the class we created. When we create our object, we want to pass in our path as discussed before, and that is our USB modem 13301. Our baud rate I've set to 9600 because on the microcontroller there's just a really simple echo program, which also if you type in stop, it'll just toggle the built-in LED, which is pretty cool. So once we've got that, we can go ahead and create some buttons so we can start interacting with the microcontroller. So this one I'm going to call open. This one will be send string, and this one will be closed, and all we're going to do is call our connection line.open serial port function. Oops, connection line.close serial port for the close button, and connection line not send data on serial port, and we'll type in stop because that's what I've programmed the microcontroller to receive, with a new line as well, and that'll toggle the LED. And once we have done that, we have to do or we can try run the program. Hopefully the console will pop up as well. It does, cool. So when we hit open, straight away we have an error, and there's not any information about that error because we didn't include it as an output in the print statement for our one of our delegate methods, but I'm not sure what one it was. This one here. But the reason that error is occurring is because we need to allow, if you double click on the project, signing and capabilities, you need to allow USB, and the error is still going to occur. So if you triple click on this new entitlement that's been added, replace USB with serial, and if we hit run again, this time the serial port was opened, and if we hit send string, it sort of breaks it up for some odd reason. But I'm looking at the microcontroller now, and it's receiving the data. So it's getting the stop command, which is pretty cool. Why it does this, I'm not sure. You know what? That's probably what I'll spend my afternoon looking into. But in terms of a really simple approach to getting some software working for communicating serially, this is how I would do it. It's just really quick and simple prototyping that you can start adding safety features around it and build up these delegate methods, as well as some of these ones that we created, like the opening and closing serial ports. Other thing is, again, I've been doing Swift for only a few months, 2 months. What is it, May? Yeah, 2 months. 3 months? Something like that. So I might not be writing it the best. This might be breaking all like language standards or whatever, but it works. So the core takeaway, key things to remember is that you have to change those entitlements. I don't actually know if you need that USB one, but I couldn't add an entitlement and type something in until I could change that. So that's how I did it, right? If I click add, what was it? Com dot. It's working now. Oops. Anyway, you need that one there. The USB one alone won't work if you're within a sandbox, a Swift sandbox like this. I think they're called sandboxes. It's like a playground, right? Well, I think that's a different thing in Swift. Anyway, I hope this was somewhat helpful. And I hope you got something important taken away. Learn something. If you have any feedback, please just let me know. That'd be amazing. If you want to see a more in-depth video or something different. Yeah, I mean, this is just the first time I found like a lack of video information online, so I thought I'll just try and fill it in and maybe build up a small collection of videos that hopefully will get better as I go, as I find little gaps in knowledge.